Today we're looking at arithmetic series and sigma notation. Now, given any arithmetic sequence, it is sometimes useful to sum all the terms in the sequence, and that summation is called an arithmetic series. So, for example, given the sequence here, 5, 10, 15, 20, and so on up to 45, we can sum those, and that would look like 5 plus 10 plus 15 plus all the way up to 45. And this sum is called an arithmetic series. Now, this particular sequence is quite short. There's not very many terms, and it's easy to sum these. However, often sequences can be quite long, and so we use sigma notation to write the summation more compactly. And sigma notation looks like this. This is a capital Greek letter. And here we have A sub I, where A sub I represents each term, in the sequence. Now we have to state what I, the range for I. So we might have I starting at 1 and going up to some finite number. So this would mean here that we are summing A1 plus A2 plus A3 all the way up to A sub n. So n terms in this sequence, and we're summing them all up. And this is called an arithmetic series. Now let's look at a more concrete example here. Suppose you had the sequence 4, 12, 20, and so on up to 740, 748. We want to write the sum of this sequence using sigma notation. So let's go ahead and do that. We need to write out a few things first. So starting with A sub 1, we know is 4. That's our first term. And we know that the common difference here, if we look at the difference between each terms, is 8. What we don't know is the nth term number. How many terms are there in this sequence? So we can find that out easily using our formula. T sub n is equal to A1 here, A1 plus n minus 1 times d. So let's fill in those, and we can solve for n. So we know this is 748. This is 4 plus n minus 1, and this is 8. So now let's distribute and solve for n. So 748 is equal to 4 plus 8n minus 8. Combining like terms gives us 748 is equal to 8n minus 4. Now we're going to go ahead and add 4 to both sides because we want to isolate n on one side. So that gives us 752 is equal to 8n. Now we can go ahead and divide each side by n, or by 8, and this gives us n is equal to 94. So now we know we have 94 terms. So I'm going to write that again up here. N is equal to 94. So we have 94 terms in this sequence. So now, using sigma notation here, so in general, we would have had A sub I going from 1 to 94, but we want to know what these are. What is A sub I? So we can use this formula again to write the general form for each of these terms. So we know that the general form, T sub n, is equal to 4 plus n minus 1 times 8. So again, let's distribute. T sub n is equal to 4 plus 8n minus 8, and combining like terms, 8n minus 4. So now we can substitute this in for here, and that will give us the specific form for this sequence. So here we would have our sigma notation. Now I'm going to use I here, 8i minus 4, where I goes from 1 to 94. Now you notice when I is 1, that gives us 8 times 1 minus 4, which is 4, and that is the first term in our sequence. Let's just go up to see those. And when it's 94, we would get 8 times 94, which is 752, minus 4, and that gives us 748, which is our last term in our sequence. So this would be the general form for writing the summation of this sequence. Now we can also go backwards. If we're given sigma notation, we can go backwards and find a sequence. So let's look at how to do that. So in this example, we might have the sigma notation for the series as 2i minus 1, where I is equal to 1, and let's go to 7 here. So just a few terms. So in the first one, we have 2 times 1 minus 1. So this is our first term. So this is 2 minus 1, which is just 1. Let's look at our second term. We would have 2 times 2 minus 1, or 4 minus 1. Our third term, 2 times 3 minus 1. 6 minus 1 is 5, and so on. You can see the pattern developing here. Let's just jump down to the last term. So this is our 7th term, because we're just going from 1 to 7. So this would be 2 times 7 minus 1, or 14 minus 1 is 13. So the sequence that is represented by this summation would be 1, 3, 5, 7, 9, 11, and 13. And the series, the summation of this, would be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13. And this is called the series, this is called the sequence, and this is the sigma notation for that.